Hello everyone, in today's video we will be reviewing your exercises from throughout the week. We will begin with this exercise that was a review of the angles that we had talked about the previous weeks. So this is mainly theory here. So the exercises begin here where it asks us to name with letters the angles in each of these letters. So we can see, let's start with delta. We can see a letter, an angle here, which I'm going to name. Just give them, we don't have to give them specific letters as names. So let's just go in alphabetical order. We have A. Here we have B. And here we have C. Next up, I have an angle here, and I have an angle here. So that's going to be D. This is going to be E. Here we have one angle in here, and two angles out there. So A, B, C, D, E, F, G, H, I is up here, J is up here. And you might have used different letters, so if you use different letters, try to basically see which ones I'm going to put where. Sorry. So try and see which angle I put where so that you can do the same. Because we need to categorize them also. We need to place them in the correct category of either acute, right, or obtuse angle. So let's get started. A, B, and C, as we can see, they are less than 90 degrees. They're pretty small, so they are all acute. So say A, B, and C all go here. Next up we have D and E, which are also small, making them acute because they are less than 90 degrees. So D and E. Then we move on to F, G, and H. So F is a pretty closed angle, so this is going to be acute, but G and H are pretty open. They are bigger than 90 degrees, so that makes them obtuse. So F goes in the acute side, whereas G and H go into the obtuse category. Lastly, we have I and J, which are both right angles. As you can see, they make this L shape, so that makes them right. I and J. Next up, we need to use a protractor to make these angles. We want to make 45 degrees, so we need to make 90 degrees, and then 110 degrees. So let's do that. I have my protractor here. Let's make it a little smaller though. Okay, so like so. Now I can place it here at the beginning of this line, and I want to make a line that is going to be 45 degrees, so it's going to start from here, and it's going to go where on this protractor? I need it to get to 45, so from 0 here, it needs to go from 45, so about here. Next up, let's take our protractor again, move it over to the next line here. And we are going to make a line that is going to be 90 degrees. So that just means straight up here, making this L shape. Next up, we move it over here. We want to make an angle that is going to be 110 degrees. So it's going to start from here and go here to get to 110. Because look, it starts from here and it goes all the way around here. It's going to go to 110. There we go. Let's move on. Okay, so now I'm going to be writing the answers in both English and Greek. So I count angles in degrees. And let's actually make this a little smaller, because it's not going to fit. Or in Greek, meters. The tool I use is called a protractor, or in Greek, myrognomonio. Next up, I separate angles based on their size. So based on their size, we divide them into, first we're going to put up right, which in Greek is orthes, which are equal, or in Greek, there. Actually, let me check that that's correctly. Yeah, we've written it correctly. Next up, we have acute angles, or in Greek, oxies, which are less, or in Greek, lιγότερο. And next up, we have obtuse, which in Greek is amvlies, which are more than 90, or in Greek, the angle that is 180 degrees is called straight, or in Greek, thea. And next up, we have the angle that is 360 degrees, which is called whole. Full, sorry. Next up, the sum of the angles of a triangle are 180 degrees. Yeah, this answer is that an angle that has all of its angles being 60 degrees is called equilateral. And in Greek, that is isopleural. Just going to put that up there. Next up, we have the separation of triangles based on their angles. So we have the right triangle, or in Greek, orthogonal. Next, we have the triangle, which in Greek is oxygonio. And lastly, we have the triangle, which in Greek is amphlygonio. Next, we want something about triangles that have one right angle. So that would make them right triangles. Or in Greek, orthogonia. And their other two angles would need to be acute. Otherwise, the sum of their angles would be more than 180. Now here, you need to figure out what you're going to put here. Are you going to put acute or obtuse? One of the two. Let's think about this. It says something about all three of its angles, meaning that it needs to be acute because in obtuse triangles, we don't have something to say about all three of the angles. One of the angles is obtuse and the other two are acute. And they have all three of their angles being acute. And lastly, we have the only one that's left, so obtuse, or in Greek, amphlygonia. And they have one side obtuse, and the other side being, and the other two angles, sorry, are acute. Yeah. Okay, so we are being asked to compare these two angles without measuring them. So without using a protractor, we are asked to see which one is bigger. So let's call this angle, let's call it angle A, and this one we're going to call angle B. We know that the bigger one is angle B. Angle B is greater because it is obtuse, whereas angle A is acute. And in Greek, that would be η γωνία Β είναι μεγαλύτερη γιατί είναι αμβία, ενώ η α είναι οξία. And that's all there is to this exercise, so let's move on. Next exercise, we are being asked some things about area. We are going to start with area immediately. And finding the area of this shape here. So first things first, it asks how many rows there are. So you can see that there's 1, 2, 3 rows. So there are 3 rows. And then it asks how many square centimeters each row has. that would be 1, 2, 3. Each row has 3 square centimeters. That means that overall it's 3 times 3, so 9 square centimeters. And if you count them, you can actually see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we have 1, 2, 3 rows again. 1, 2, 3 rows. But this time each row has 5 square centimeters. So to find how many there are, I would have to do 3 times 5, which makes 15 square centimeters. Next up, it wants us to separate these shapes into square centimeters, basically. So we got to follow the dots here. So let's just connect the dots that are across from one another, and we'll see what we get. And here where it ends, it's supposed to close. And this is supposed to come across. Well, that didn't come out exactly right. Actually, no, the top one is a little skewed. Okay, so we have here 3 rows, but each row has 7 square centimeters. So overall, that's 3 times 7 makes 21 square centimeters. Let's move on to this one. Here, let's first close this box off. So here and here. And we're going to put another line here. And then 2. And then 1 here. 1 here. And so on. And what we get is 2 rows with each row having 4 and 4, 8 square centimeters. So that's an overall 2 times 8, 16 square centimeters. Here we want to color the shape so that it has 12 square centimeters. So we need to think of a multiplication that makes 12. The first one that comes to my mind is 3 times 4. So we're going to do 1, 2, 3 rows, and then having each row have 4 boxes. So 1, 2, 3, 4. And then I'm just going to fill the rest in. And there you go. If you count this, it's going to be 12 square centimeters. But you didn't have to do it like that. You could have made a box that has 2 rows and 6. So 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5, 6. And then just color the rest in as well. So there you go. That's 12 as well. Either one would have been acceptable. Or you could have placed them somewhere else. You didn't have to have them up here on the left necessarily. Could have been down here. As long as they were 12 boxes. Anyway, let's move on to the next one. The next one says, let's see. The square has a side of 35 centimeters. How much is its perimeter and its area? So if it has a side, each side is 35 centimeters, that means that to find its perimeter, I would have to do, oh, let's actually make that a little bigger. Let's take it to 14. Let's say for its perimeter, we are going to multiply we're going to need to multiply the sides by 4. So 4 times 35. And 4 times 35 gives me 140. For the area, I would need to do 35 times 35. And if you don't remember why, you can go back to the video where we explain how to find perimeters and areas for each shape. So let's do 35 times 35. 5 by 5 makes 25, so write 5, carry 5. 5 times 3 makes 15. Plus 2 that I carried over makes 17. Write 0 beneath the 1s, and then 3 by 5 makes 15. Write 5, carry 1. 3 by 3 makes 9, plus 1 that I carried over makes 10. I add, and I get 5, 2, 2, 1. So my result is going to be equal to 1,225 square centimeters. And I forgot to write centimeters in the perimeter answer. Next up, we have a rectangle that has a perimeter of 64 meters. One of its sides, its smaller side, is 12 meters. What is the perimeter, the other side, sorry, of the rectangle, and what is its area? So let's see here. We have a total perimeter of 64 meters. That means that, let's call this side A, and this side B. Right? Well, if this side is A, then this side is also A, and this side is also B. Now what we know is that to find the perimeter, we need to do 2 times A plus 2 times B. And we know that this gives us 64 because we're told that that's the perimeter of the shape. So we know that this is 64. But we also know that one of the sides is 12. So here, instead of A, I'm going to put in 12. Okay? Now 2 times 12 makes 24, right? So whatever this B is, it needs to be something that when multiplied by 2 and then having 24 added to it, it makes 64, right? Now, what does it need to be so that when I add 24 to it, it gives me 64? Basically, we're trying to think 24 plus what gives me 64? And the answer to that is, well, the difference between 24 and 64. And now the difference between 64 and 24 is 40. So 2b needs to be, in order for this to work, needs to be equal to 40. Okay, great. But can I use this to find the length of one side? Well, yeah, because I can think, well, what number do I multiply with 2 and get 40? The answer to that would be 20. So B has to be equal to 20. The other side needs to be equal to 20. So that's the other side. B is equal to 20. But what about the area? Now to find the area, I can multiply A and B. So A times B. So what I'm going to say is area, area is equal to A times B, which is equal to 12, because that's one side, times 20, which is the other. And 12 times 20, and this is meters, and this is also meters, as was stated here. And 12 times 20 gives me 240 square meters. There you go, that's the area. Next up, we have a rectangle that has one side being 34 and the other side being 16. And we're being asked to find the area. Well, the area is going to be 34 times 16. And this is in meters. So let's do that multiplication vertically. 34 times 16. 6 by 4 gives me 24, right? 4, carry 2. 6 by 3 makes 18, plus 2 that I carried over makes 20. 0 beneath the ones, and then 34 here. Add. 4, 4, 5. So my answer here should be 544 square meters. Next up, a triangle has one side of 9.5 meters and another side of 6.4 meters. What is its area? So here we need to find the area. We need to do 9.5 meters times 6.4 meters. We're going to do this off to the side. So 9.5 times 6.4. 4 times this is going to give me 380. To those of you that have said, that have asked about the dog, I'm really sorry, but it keeps barking. I really can't find an hour where it stops barking to record these videos. So unfortunately, we are going to have to listen to it barking. So we get 6,080. 6,080 square meters. Last one here. We need to find the area of this entire shape. How do we do that? It's like that one exercise we did. We need to find the area of this triangle, then this rectangle, and then this triangle, and add them together. But if you pay close attention, you'll see that this triangle has the same dimensions as this triangle. So if we find this one's area, we can assume that this one is the same. So let's find the area of the rectangle. That would be 2 times 3, because one side is 2, and this is in centimeters, times 3 centimeters, which would be equal to 6 square, and sometimes square you can just write it as a SQ. So square meters. Next up, the area of one triangle is going to be 4 times 3, and whatever we find divided by 2. And all this is going to be also in square centimeters. Yeah, why did I write meters above? So 4 times 3 gives me 12, divided by 2 would give me 6. Let's actually write that out. 12 divided by 2 square centimeters, which is equal to 6 square centimeters. And that's the area of one triangle, right? So the overall area, let's write it down here. Overall area is going to be equal to the area of the rectangle plus the area of one triangle plus the area of another triangle, which means the overall area is going to be equal to 6 square centimeters plus another 6 square centimeters plus another 6 square centimeters to give us an overall of 18 square centimeters. And that's how we find the area of that shape. And if you want to look at the answers again at any of the exercises that I've already done, you can go back and check them and pause the video at the point that you need. Next up, we want to guess the area of the shapes that would be here if they were complete. So what we can guess from here is that there are going to be 1, 2, 3 rows, and that each row is going to have 4 square centimeters. So 3 times 4 would give me 12 square centimeters. Here there would be 1, 2, 3, 4 rows with each having 1, 2, 3, 4, 5 square centimeters. 4 times 5 would give me 20 square centimeters. Next, I want to make a square that is going to have a side of 4 centimeters, and then I want to find its perimeter and area. So here you could take a ruler and measure the sides to be 4 centimeters. I cannot do that, unfortunately. So let's just pretend that this is 4 centimeters. Each of these sides, let's imagine, is 4 centimeters. Then its perimeter would be 4 times 4 centimeters. Careful, 4 is because it's a square, and I'm doing 4 plus 4 plus 4 plus 4, that's 4 centimeters. It's not 4 centimeters times 4 centimeters that would give us square centimeters. It's just a 4 because I'm adding 4 fours. So I'm going to get 16 centimeters, just centimeters. Its area, on the other hand, would be 4 centimeters, which is one side, times another 4 centimeters, which is the other side. And this would give me 16 square centimeters. Difference. Important difference. One shows area, the other shows length. Next up, we want to make a rectangle that has one side of 5 and another side of 3. And then we want to find its perimeter and its area. So again, I don't have a ruler, so we're going to pretend you could use a ruler and make this correctly. We're going to pretend that this side is going to be 5. This side is going to be 3. Actually, I've made I've made the one side ridiculously big. Okay, so let's say if this side is 3, then the other side should be about here. So this side is going to be 3 and this side is going to be 5. The perimeter is going to be given to us by doing 3 centimeters, sorry, 2 times 3 centimeters plus 2 times 5 centimeters, which is going to give me 2 times 3 would give me 6 centimeters plus 10 centimeters, which would give me 16 centimeters. Area would be given to us by doing 3 centimeters times 5 centimeters, which would result in 15 square centimeters. And that's how we find the area of that rectangle. And that will be all for today. So, yeah, apparently I will see you guys again on, oh no, I won't be seeing you guys again. So, have a good Easter and see you guys again after Easter. Do your homework as well and stay inside. Uh, have a good time over the holidays.